Okay, cool. Okay, cool. So, can you guys see me here? Let's create a new Canva. Okay, this seems to be working. Okay, ladies and gentlemen, welcome to the live stream. So today we'd like to, firstly, what we're gonna do is we were, we're gonna read some paper and I'm gonna show you how I personally organize and read papers. And so let's start from here, shall we? Okay, gonna introduce a little bit more myself. My name is Warren. I am a quantum machine learning and machine learning researcher, and I'm studying at University of London for my undergrad. And I already published some of the papers on quantum machine intelligence journal, and I'm also the peer reviewer and author of 2025 ICLR conference. And so I'm really excited to share how I personally use my technique to, and with the application Obsidian to read papers. And I'm going to walk you through this a little bit more. So today what I want to talk about is I'm working on research. So the research idea is called quantum. It's about building a. So what we're going to do is we wanted to do literature review for these papers, and this one is called formulating quantum kernel machine for language modeling. So what we're going to build is build a neural networks. We call it quantum kernel machine, and we're trying to formulate a mathematical model behind what's going on within QKM, and we want trying to do this with language modeling using transformer architecture. So that's basically the whole idea of what we are working on recently. And so we're starting with, okay, so we need to search for some keywords. So quantum, kernel machine, kernel method. So let's see, I'm gonna check it out. So some of these papers are pretty famous, like quantum machine learning, supervised quantum machine learning or kernel methods, and another pretty famous one is from Nature's communication. So quantum machine learning beyond kernel method, and what can be done with this kind of architecture. So like we can talk about like when you're looking at the papers, we can just like start with the very raw sense of like you need to turn on your radar and to scan what are the top papers that is available to you in this domain. And so we can talk about like, and the way to do that is you need to okay, so this one here. So okay, we can start with some of the top papers here. So quantum machine learning feature Hilbert space. Okay, it's pretty famous one. So we're starting with this one here, and we can talk about like how we actually do this to read and like organize information in a very elegant and efficient manner. So let's start with the Obsidian, and to better visualize this, we're gonna use line models. Okay, cool. So turn on light mode here, so we can have better visual on what's going on. Okay, cool. So let's just put it over here. Cool. So here it's like we need to talk about like how to actually read a papers. For any paper, especially in STEM, we will focus on firstly abstract, and once you kind of understand the broad sense of what's going on within the paper, within the study, which essentially is what abstract does for this article. So we're going to talk about like, okay, so what is abstract meaning about? So most of the abstract, I would say abstract will follow some of the structure that is, we'll talk about like the background, what, and especially talk about like why, the reason why we're trying to do this, or the reason why this, we should do this research. So the basic idea of quantum computing is surprisingly similar to like current machine learning in an effective performing computation in incredibly large hyperspace. In this paper, we will explore the theoretical foundation. So the paper is about theoretical foundation. It's about the formulation, the theoretical formulation of this method, like quantum machine learning, and also kernel method, quantum kernel method, and also it was just basically formulating this using a quantum computer can analyze input on future space from interview or discuss two prototyping quantum models for class application and so forth. So especially we're basically talking about like some of the commonly used method for quantum machine learning, especially for a class application program. And also based on this objective, we also can have a formulation on the theoretical aspect or perspective on this problem. So once we're already done, most of the amateurs, like student or amateurs researchers, they were starting from introduction all the way down to the conclusion and all the way down the appendix. But I wouldn't suggest that. I would start to suggest you, once you understand the broad, like big picture of this paper, we highly recommend you starting from conclusion or summary of this paper, or at least from the discussion, to talk about like to see what is the final like conclusion made within this idea this paper. So in this paper, we introduced a number of new ideas for area of quantum machine learning based on blah blah blah. And so the core idea is interpreting the encoding input in quantum state as a feature map with associated quantum hyperspace with a feature space. Inner part of quantum state in this feature state can be used to evaluate a kernel function. We can alternatively chain a variational quantum circuit as an explicit classifier in feature space to learn a decision boundary. So we introduced a squeezing feature map as an example and innovative wide-scale simulation that this two approach can lead to interesting results. So basically talked about like basically formulating this idea of like now quantum machine learning can be used in supervised machine learning, and especially the whole idea is like quantum machine learning, supervised quantum machine learning is a kernel method. So it's pretty, we can also correlate it with this research with this one here, supervised machine learning or kernel method. It actually comes from the same author, Marina Forshado. So it's pretty close. This idea is that, so this two paper is pretty similar. So the idea is what we're gonna do here is to edit web page. So we're gonna do this. Is to have paper copy and paste. Here, so we can have reference. So here's the fun part. So we can enlarge this one here. So I can draw some map about this further. Quantum machinery. So here we go. So we're going to start to draw a knowledge tree or a knowledge map. You can call it mind map in much simpler term. It's like quantum machine learning. Okay, so okay, so we have supervised learning. Supervised learning. So we have supervised learning and also unsupervised learning, but it's not within the scope of discussion in this paper. It is not now. And later on, we will have so supervised learning, there's a method called kernel method. So the idea is to turn this kernel method, how to formulate a kernel using quantum machine learning model. So, so the question here, so we will start off with some questions. So we will start with, so basically doing research, the first thing you're gonna do is ask questions. It's very important. I would say the most important thing. So what is quantum machine learning? What is supervised quantum machine learning? And why? How to formulate quantum kernel method for supervised. Yeah, that's pretty much it. So based on reading just some simple idea from this paper, we've already seen the correlation among this. So we can start with